section 6.3, radicals and rational exponents. So this is kind of a really weird section because it can be really easy or really hard. And the reason for that is one simple word: calculator. All right, so if we have a calculator, this section you can blow through with no problem. It's just using your calculator and you're kind of done. However, if you don't have a calculator, it gets really complicated and you got to do a lot of scrap work. So I'm gonna show you maybe one or two hard things, and that's really about it. But for the most part, I'm gonna be honest with you, some of the questions that we're going to be going through, I cannot solve without a calculator if I want to if I want to get this done quickly. Could it be solved without a calculator? Absolutely. But just be aware, it is very time consuming and you need to kind of know what's going on. So let's I've been beating around the bush. Let's go ahead and jump into this thing. It says when b to the n power equals a for an integer n greater than 1, b is an nth root of a. All right, there's a lot of jibber jabber there, but look at this. You've seen this before. You're used to something like this where I'm looking for the square root of 4. This is the same concept, but this time I actually have a variable on the outside of n. So in this case, I'm looking for the nth root of a, where this one I was looking for the square root or the second root of 4. This one I'm looking for the nth root. So basically what I'm asking you to do is this. It's asking what number when multiplied by itself n times equals a. Case in point, let's do, just to show it to you, if I give you this, I am asking for the fifth root of 32. What number when multiplied by itself 5 times will give me 32? And that's kind of what's happening. All right, the next little rule to this to kind of keep in mind is this. The nth root of a positive number can be written as a power with base a and an exponent of 1 over n. Okay, what is all this about? So basically, if I take a number and I raise it to a fraction, I can simply rewrite this to say the fourth root of 16. Basically, this denominator in my exponent's fraction becomes the root of my in my radical. All right, so I basically rewrote this. These two are literally the same thing. 16th to the 1/4 power is really saying what number multiplied by itself 4 times gives me 16. What's the fourth root of 16? And the same thing can be done here, but this time the root is still going to be 4 because that was in my denominator, but the numerator of this stays as my exponent. So if I were to rewrite this, it would be saying 16 to the 3/4 power, or what is a number multiplied by itself 4 times that is equal to 16 to the 3rd power. And this is where, like I said, things could get really complicated really fast. If I were to solve this by hand, I would have to do 16 by 16 all by 16 all over on the side here, and then whatever number that is, and I'm being just out of curiosity, what is that number? It would be 4,996. I'm asking what number when multiplied by itself 4 times gives me that, and now it's just a matter of I'd have to do trial and error again. And like I said, this is really a pain when I don't have a calculator. But if I were to do all this correctly, I would find out that 8 is the answer. 8 multiplied by itself 4 times is the answer, and I can prove it right here. I can say 8 times 8 times 8 times 8, and I get that. So how do I do this easier in the calculator? Well, this is where we're just going to get right on to it. So it's telling me to simplify the expression. Using your handy dandy calculator, you have a little thing. Let's clear this out. So it says the fifth root of 243. So this is how you type it. You're going to hit the number 5. And then if you go to the math button, press it, And look at here. There has this variable, it's got an x and then it's got a radical sign. This is what you want to hit. So press 5. And what this is saying is the 5th root. So that 5 goes into place of that x. So it's the 5th root of 243. Hit enter. Up, I'm 3. I'm done. I simplified the expression. Now, could I have done this without a calculator? Yes, I could have, but it would have taken a lot of guess and check. I would have gone 1 times 1, 2 times 2, 2 times 2 times 2, 3 times 3 times 3. It would have took a lot of guessing and checking. Well, let's do one more with you. I'm doing the third, whoops, get on the screen. I'm doing the 3rd root of 64. So I'm doing the 3rd root, math, and then I'm going to hit 5. So I'm looking for the 3rd root of 64. In this case, it's 4. Pretty straightforward. All right, now, what about this? Well, this is where your calculator is so awesome, and you can do this 2 ways. One way is by simply plugging it in, just like you see. 144 raised, there's that house top button. I'm going to raise it to an exponent, raised to the 1/2 power. So I'm going to put 1/2 as a fraction in there, or I could have put 0.5, it would have been fine. And when I do that, when I literally put it in the calculator, just like I see it, I hit enter, I get 12. All right? Well, the other way is to do that rule about with rational exponents. I know that I can rewrite this as the 144 with a 2nd root on the outside. Well, technically, we don't normally, when it's a 2 like this, it's still the square root. So what number multiplied by itself 2 times gives me 144? Well, you should know this already. 12 times 12. So the answer is 12. And we can plug that into our calculator as well. 2, math, then 5. And then I could put 144, gives me that. But remember, when it comes to the 2nd root, we automatically have that as 2nd square root. We normally do that. Okay, it's just the second root and the square root are the same thing. We just don't normally put the 2 in there. All right. So guys, that's pretty much it. I mean, there's nothing more to this. Literally, you can plug every last one of these things in your calculator in one of 2 ways. I can literally plug this as 729, raise the roof to 1/3, and I am done. And I've got my answer. And you can do this with all of them. Take a little bit of practice if you want, and come back at the end here. So like I said, pretty easy peasy, lemon squeezy. Just plug it in and you're done. There's really no other way to do this outside of literally guessing and checking. And that's basically it. So let's look at 8 here. The radius of R of the base of the cylinder is given by this equation, all right, where V is the volume of the cylinder and H is the height of the cylinder. Find the radius of the cylinder to the nearest inch. All right, so what we're going to do is we know a couple things. We know the volume and we know the height. So we're going to take this equation and we're going to plug everything that we know. We know the volume to be 170. Divide by pi, and we know that to be 6 as my height, and all of this is going to be raised to the 1/2 power. So let's simplify the inside of our fraction. Basically, we're going to do PEMDAS. So now that I've got this done, I've noticed I had made a mistake here, so I had to kind of went back and check my numbers, something was wrong. So I plugged everything in. I'm going to rewrite this again. So I'm going to say that radius is equal to 170 divided by 6 pi, and all of that is being raised to the 1/2 power. All right. So what I'm going to do is, this is where things get a little bit confusing. Notice that this 170 is being divided by both 6 times pi. So when you go to put it in your calculator, and this is actually what I did wrong a while ago off screen, I divided it by 6 pi. Now I want you to look at what I get, and then I'm going to put something else in there. Divide by parentheses 6 pi. And when I put enter this time, I get this. Now, the second one is the actually one that is correct, because I have to find out what 6 times pi is first before I can do my division. So I do 170 divided by 6 pi, and I get this number. So that's one reason why when you go to put this in your calculator, because this is more important than just the 170, we need to put it in parentheses. Otherwise, it might mess you up. All right, now that we've done that, we can go ahead and say that R is equal to approximately 9 point something something raised to the 1/2 power. We can use our calculator to help us out in this. I'm going to raise, just hit the raise button, and it's going to do this. It says A and S raised to 0.5, or 1/2. What I'm telling my calculator to do is this. I'm raising my last answer of 9.1 to 1/2. When I do, I get 3, approximately 3. So radius of this thing is approximately 3 inches. All right, and we can kind of prove that. So if we go back and remember from several years ago or whatever, the volume of a cylinder is equal to pi r squared times height. So if this is correct, I should get pi times 3 squared times 6 should get me close to 170. Let's plug that in. I have pi times 3 squared times 6 gives me 169. So that's pretty accurate. So because we had a rounding, it's not exactly perfect. So yes, this does work. All right. So that's it for this video. Like I said, this can be really, really easy or really, really hard, all depending on one simple thing, your calculator and being able to use it. You know where to find me if you got questions, and I'll see you in the next one. Bye-bye.